Okay. So last class we discussed about implicit differentiation. We are going to discuss different methods of finding derivatives. In the last class we have seen how to find the derivative of implicit functions. And now derivatives of inverse trigonometric functions. Derivatives of inverse trigonometric functions. Derivatives of trigonometric functions we know. Derivative sin x is cos x, derivative of cos x is minus sin x, like that. So for example, y is equal to sin inverse x. Y equals sin inverse x. We have to find the derivative of this function. So we can write this as y is equal to sin inverse x. Then that means x is equal to sin y. X is equal to sin y. We can differentiate both sides. ये शिव प्रसाद गुले कितना सिस्टम से लॉगिन कर रहे हैं 3 और 4 ऐसे differentiate both sides with respect to x, implicit differentiation. Derivative of x with respect to x is 1 is equal to derivative of sin y. It is of the form sin x. So using chain rule, sin x का derivative cos x. So sin y का derivative cos y, but x के जगह y था उसका derivative से multiply करना. So derivative of y with respect to x is dy by dx. So from here you will get dy by dx is equal to 1 by cos y. And now we need to write the result in a standard form. This is 1 by, हमें पता है कि sin square y plus cos square y is equal to 1. Sin square y plus cos square y is equal to 1. So cos square y is equal to 1 minus sin square y. So that means cos y is equal to under root 1 minus sin square y. So you can write like this. It is equal to under root 1 minus sin square y. That is dy by dx is equal to 1 by under root 1 minus sin y is equal to x. So sin square y is equal to x square. So 1 minus 1 by under root 1 minus x square. So derivative, that is y, your y is sin inverse x. That means you can conclude that derivative of sin inverse x, derivative of sin inverse x is 1 by root 1 minus x square. Similarly, we can prove the result for other functions also. like y is equal to tan inverse x. So from here you will get x is equal to tan y. Differentiate both sides with respect to x. Differentiate both sides with respect to x. Derivative x is 1. Derivative of tan x is sec square x. So derivative of tan y is sec square y. But x के जगह y था उसका derivative से multiply करना into dy by dx. That means आपको मिलेगा dy by dx is equal to 1 upon sec square y, which is equal to 1 upon, आपके पास जो अपने फॉर्मूला पढ़ाई किया था 1 प्लस tan square x is equal to sec square x. So sec square y को आप लिख सकते हैं 1 upon 1 plus tan square y, which is 1 divided by 1 plus tan y को हमने x दे दिया था, it is 1 by 1 upon x square. That means dy by dx is equal to 1 upon 1 plus x square. So your y was tan inverse x. That means derivative of d by dx of tan inverse x is equal to 1 by 1 plus x square. Similarly, in the same way, using implicit differentiation, you can prove the or you can find the derivatives of all trigonometric functions, inverse trigonometric function. So derivative of sine inverse x is 1 by root 1 minus x square. Derivative of cos inverse x is equal to ओनली 1 माइनस साइन आएगा -1 बाई, सो पढ़ाई करने के लिए आसान है, 1 बाई रूट 1 माइनस एक्स स्क्वायर. सो साइन इनवर्स एक्स एंड कोस इनवर्स एक्स का डेरिवेटिव इट्स ऑलमोस्ट सेम, ओनली थिंग इज साइन इनवर्स एक्स का पॉजिटिव 1 बाई अंडर रूट 1 माइनस एक्स स्क्वायर, कॉस इनवर्स एक्स का -1 बाई अंडर रूट 1 माइनस एक्स स्क्वायर. देन डेरिवेटिव ऑफ tan inverse x is equal to 1 by 1 plus x square. Derivative of cotangent inverse x, it is -1 by 1 plus x square. Only 2 we proved, the remaining you can prove it in the same way. I just want to tell you all the result. Derivative of sec inverse x is equal to 1 by x into under root x square minus 1, and derivative of cosecant inverse x is equal to -1 by x into under root x square minus 1. So ऐसे पेयर में पढ़ाई करना आसान है. साइन इनवर्स एक्स एंड कॉस इनवर्स एक्स दोनों का डेरिवेटिव सेम है ऑलमोस्ट, ओनली थिंग इज प्लस और माइनस. हाँ या
सर सेक इनवर्स एक्स का मॉड्यूलस एक्स है ना वहाँ पे 1 बाय मॉड्यूलस एक्स इनटू अंडर रूट एक्स स्क्वायर माइनस 1.
सेक इनवर्स एक्स का मॉडुलस वाला कुछ नहीं है. किधर मॉडुलस?
सर वो मतलब कुछ मैंने भी देखा है, मतलब जब वो
एक्स का मतलब
जैसे
इनवर्स एक्स का डेरिवेटिव है ना,
बोलो. सो उन्होंने बोलो ना
सर. वो सेकंड इनवर्स एक्स का है ना, सेक इनवर्स एक्स और कोसेक इनवर्स एक्स, उसमें जो एक्स है ना बाहर, उसमें मॉड लगा हुआ है.
Okay, 1 second, I will check and tell. कभी जो sometimes to make the function as invertible, sometimes make it positive we may use, but normally we don't use that. This is the formula we are using. So when that modulus x or why that modulus x is using, that I will tell you after checking that I will tell you. Okay. So normally this is a result we are using 1 by x into under root x square minus 1. So but वो जो domain, या इसका जो डोमेन्स रहते हैं, मैंने डोमेन्स के बारे में ज़्यादा स्ट्रेस नहीं किया, इसका डोमेन रहते हैं जैसे माइनस इन्फिनिटी टू -1 यूनियन 1 to infinity, क्योंकि sec inverse x does not exist between -1 and 1. So like that value said, modulus is not जरूरत actually. I think there is no need of modulus, क्योंकि जो whatever the value of x पॉजिटिव और नेगेटिव है तो x स्क्वायर विल बी पॉजिटिव, सो स्क्वायर रूट के अंदर का चीज पॉजिटिव ही आएगा. Okay. And what situations we have to use that modulus, that I will tell you later. I will check it and tell you. Normally this is the formula. Clear?
Yes, sir.
Yeah. So only we proved only two results here. One is sin inverse x we proved and tan inverse x is we proved. Others also the same thing, same steps, same, everything is same. So you can do it. Now, we'll go back to the exercise. So last class we were discussing some questions on exercise 5.3 using implicit differentiation. Then 9 to, जैसे this also I don't want to spend much time on this same type of question है. Exercise 5.3 question number 9 से लेके 15 तक it's same thing, like same type of question. See question number 9, y is equal to sine inverse 2x divided by 1 plus x square. So this is sine inverse x. So here one problem, if you directly going for, you can go, but the problem is like, say this is y is equal to sine inverse x form. So sine inverse x है तो हमें पता है कि derivative is 1 by root 1 minus x square. So ये हो जाएगा ऐसे 1 by, just दिखा रहे root 1 minus 2x by 1 plus x square का square. So 1 by root 1 plus 1 minus x square. But y के जगह 2x by 1 plus x square था, so उसका derivative से multiply करना. So here this is again you have to use quotient rule and all those things. So this process will become little lengthy. So we'll use some techniques sometimes. इसको बोलते trigonometric substitution बोलते हैं. Before applying derivatives, you can make a small substitution. You put x is equal to tan theta. We are not finding the derivative. We are just giving a substitution and try to simplify this function. Y is equal to, this is sine inverse 2 tan theta divided by 1 plus tan square theta. But 2 tan theta by 1 plus tan square theta is sine 2 theta. आपने जो last year पढ़ाई किया था double angle formula में. So sine inverse sine 2 theta. So this is equal to sine inverse sine x is x. So sine inverse sine 2 theta is x. That means आपको मिला है y is equal to 2 theta. So that is 2 into tan theta is equal to x है, तो इसमें से आपको मिलेगा theta is equal to tan inverse x. So that means y is equal to 2 tan inverse x. So आपने उतना बड़ा फंक्शन को सिंप्लीफाई करके ऐसे लिखा है कि y is equal to 2 tan inverse x. देखो, if you go for direct chain rule, it would take a long time. First it is derivative of sine inverse x is 1 by root 1 minus x square. But इधर x के जगह 2x by 1 plus x square था, उसका derivative से फिर से multiply करना. Then you have to apply quotient rule there. So it is getting lengthy. But now here what we have seen, we put one substitution x is equal to tan theta. Then your function becomes very simple. It is y is equal to 2 tan inverse x. So हमें चाहिए था derivative. So dy by dx, right side is constant into function. So constant into derivative of tan inverse x is 1 by 1 plus x square. So answer is 2 by 1 plus x square. So it is finished. So these kind of substitutions make our work very easier. And substitution method is one of the, like I say section बोल के हम problems नहीं करते हैं normally, but substitution method is one of the most important techniques to find the derivative by giving proper substitution. वो कैसे है, आप जब आप ज़्यादा प्रॉब्लम करते हैं तब आपको आइडिया मिल जाएगा, नहीं तो ऐसा रट्टा मार्क नहीं कर सकते. कौन सा फंक्शन सब्स्टिट्यूट करना, इधर tan थीटा का अलावा दूसरा कोई फंक्शन आप सब्स्टिट्यूट करेंगे तो कोई फायदा नहीं होगा. So what to substitute, when to substitute, you will get the clear idea when you practice more and more questions. Next question देखो. Y is equal to tan inverse 3x minus x cube divided by 1 minus 3x square. So you have to find the derivative. So here it is inside bracket देख लेना. डायरेक्ट आप सब्स्टिट्यूशन मेथड जाएंगे तो प्रॉब्लम हो जाएगा. प्रॉब्लम हो जाए मतलब बहुत लंबा हो जाएगा. 1 by 1 plus x square, इधर x के जगह 3x minus x cube divided by 1 minus 3x square है. Then we have to use the chain rule, so it will take the process very lengthy way. So you can see that this is something 3x minus x cube divided 1 minus 3x square. ऐसे कुछ फॉर्मूला पढ़ाई किए कि याद रख देना, जैसे 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. That is actually definition or formula for tan 3 theta. So you have to put x is equal to tan theta. So your function will become y is equal to tan inverse ब्रैकेट के अंदर 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. That is tan inverse, that is nothing but tan theta. Tan 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta is tan 3 theta. And this you studied in last year. That's why I told you that most important chapters are trigonometric function and limits and derivatives from the 11th class. And tan inverse tan x is x, so this is equal to 3 theta. So आपको मिला y is equal to 3 theta. That is 3 into, so इधर से आपको मिलेगा, आपने x is equal to tan theta दिया था, so theta is equal to आपको मिलेगा tan inverse x. So it is 3 tan inverse x. So dy by dx is equal to 3 constant. 3 into derivative of tan inverse x is 1 by 1 plus x square. So that's all. That's the answer. Understood? Now, 11 I am skipping. I'm going to 12. Because 11 also the same thing only. Sine inverse 1 minus x square divided by 1 plus x square. So you can put x is equal to tan theta. So you will get y is equal to sine inverse 1 minus tan square theta divided by 1 plus tan square theta. This is sine inverse 1 minus tan square theta divided by 1 plus tan square theta is not sine 2 theta, it is cos 2 theta. पहले हमें साइन इनवर्स साइन, कॉस इनवर्स कॉस, टैन इनवर्स टैन ऐसे मिला था, इधर साइन इनवर्स कॉस मिला। इसको क्या करेंगे, दिस इज साइन इनवर्स cos थीटा एंड sin थीटा आर co फंक्शन, सो cos 2 थीटा को आप ऐसे लिख सकते हैं sin pi by 2 minus 2 theta because sin and cos are co functions. So हमने cos 2 theta को sin 90 minus theta, sin pi by 2 minus 2 theta form में लिखा. Now sin inverse sin theta is sin theta, so y is equal to pi by 2 minus 2 theta. That is pi by 2 minus 2, theta is x is equal to tan theta, theta is equal to tan inverse x. So now derivative pi by 2 constant derivative is 0 minus 2 into derivative of tan inverse x is 1 by 1 plus x square. So the answer is minus 2 divided by 1 plus x square. Question number 14. Y is equal to sin inverse ब्रैकेट के अंदर 2x इंटू अंडर रूट 1 माइनस एक्स स्क्वायर, साथ में दिया कि माइनस 1 बाई रूट 2 लेस दैन एक्स लेस दैन 1 बाई रूट 2. So here we'll put x is equal to sin theta. So this becomes y is equal to sin inverse 2 sin theta bracket के अंदर into 1 minus sin square theta. That is y is equal to sin inverse 2 sin theta, 1 minus sin square theta is cos square theta, under root cos, that is cos theta. Then sin inverse 2 sin theta cos theta is sin 2 theta. That means sin inverse sin theta is theta. So y is equal to 2 theta. But theta is sin inverse x. So y is equal to 2 into derivative of the sin inverse x is 1 by root 1 minus